Looks like a Windows My PC, right? But this is not a computer, it's an ESP32. And today, I'll show you how it displays its internal and external flash storage, just like a PC. In this project, we will connect 16 megabytes external flash chip to ESP32. We will build a captive portal that shows both internal and external memories, and then write, erase, and format demo files live. Plus, I'll explain how this fits with the other memory types inside every microcontroller. Same chip can also be found on Wemos D1 Mini with 4 megabytes flash memory. Before diving in, let's see the 7 types of memory that live inside or around a microcontroller. First, we have ROM, permanent memory, that comes pre-programmed with things like the bootloader. It can't be changed, and it's what makes sure the microcontroller starts up correctly every time. Then there's SRAM. Think of this like your PC's RAM. It's fast, but volatile, meaning data disappears when the power is off. This is where variables and temporary data are stored during execution. Next is RTC memory. This is a small memory block tied to the real-time clock. It's special because it survives deep sleep, perfect for keeping a few values while saving power. We also have EFUSES, one-time programmable fuses that store things like the device's MAC address, security keys, or factory calibration data. Once set, they can't be changed. Some microcontrollers also have EEPROM, used to store small settings like Wi-Fi credentials. On ESP32, this is usually emulated using Flash. For projects that need extra working memory, like AI, images, or buffering large data, there's PSRAM. It works just like extra RAM you can plug into your PC. Finally, we come to external SPI Flash, like the W25Q128 in this demo. This acts like a pen drive for your microcontroller. You can write files, clear them, or even format the chip, exactly what we'll be testing today. Before we start wiring, let's take a quick look at the components used in this project. Let's talk about the board I'm using, the DFRobot Beetle ESP32 C6. This little board is built around latest ESP32 chip, which runs on a 32-bit, RISC-V, single-core processor, clocked up to 160 MHz. It supports the brand-new Wi-Fi 6 standard and Bluetooth Low Energy, perfect for low-power wireless control or sensor data transmission. Despite its small size, the Beetle board gives you plenty of GPIOs. There's an onboard USB-C interface for easy programming. Overall, it's compact, efficient, and powerful, a great choice for advanced IoT experiments and demonstrations like this one. Next is the W25Q128, a 128 megabit SPI Flash memory. That's 16 megabytes of external storage space. It connects using just 4 data lines: MISO, MOJI, SCLK, and CS. This is where we'll write, clear, and format demo files in real time. Now let's connect our external flash to the ESP32. The chip runs on 3.3 volts, so make sure not to connect it to 5 volt. Otherwise, you might damage it. Take red wire and connect VCC pin of the flash memory to 3.3 volt pin of the ESP32. Take black wire and connect ground pin of the flash to ground pin of the ESP32. Take yellow wire and connect CA's pin of the flash to pin 7 of the ESP32. Take orange wire and connect D0 pin of the flash to pin 5 of the ESP32. Take green wire and connect clock pin of the flash to pin 4 of the ESP32. Take gray wire and connect D1 pin of the flash to pin 6 of the ESP32. And now we are ready to upload the sketch. The Arduino sketch starts by setting up little EFUSES for internal storage and initializing the flash chip as external storage. It creates a Wi-Fi access point and launches a web server, which hosts our captive portal page, the one that looks like Windows, My PC. The status endpoint sends live JSON data about both memories, total size, used space, and file lists, which the HTML page uses to update the bars and tables in real time. The other endpoints, write external, clear external, and format external, handle writing a demo file, clearing the reserved area, and formatting the entire flash chip. Hit upload and sit back to view demo. Now we are inside the captive portal, and you can see both drives, the internal flash on the left and the external flash on the right. When I click Write Demo File, the ESP32 writes a data block directly into the external flash memory. Watch the table update. A new entry appears instantly with the file's address, size, and write time in milliseconds. When I click Format External, the ESP32 completely erases the chip, sector by sector, giving us a clean, empty flash ready for new data. When I click Erase External, only the reserved demo area of the flash is cleared, without touching the rest of the data on the chip. This project turns an ESP32 into a live web-based flash manager, showing, writing, and formatting files on a W25Q128 external SPI Flash. In this video, we saw how a 16 MB chip can expand that storage and work just like an external drive. So here is an idea. If you would like to see me replace the Wemos D1 Mini's 4 MB flash chip with a 16 MB version, drop a comment below and let me know. I might make the next upgrade tutorial. Till then, I am DHK Dude, signing off.